Intel and NVIDIA to jointly develop AI infrastructure and personal computing products. Intel to design and manufacture custom data center and client CPUs with NVIDIA and NVLink. NVIDIA to invest $5 billion in Intel's common stock. Santa Clara, California, September 18th, 2025. NVIDIA and the Intel Corporation today announced the collaboration to jointly develop multiple generations of custom data center and PC product and accelerate application workload across the hyperscale, enterprise, and consumer market. Companies will focus on seamlessly connecting the NVIDIA's and Intel architecture using the NVIDIA Link, NVLink, integrating with the strength of the NVIDIA's AI and accelerated computing with the Intel leading CPU technologies and x86 ecosystem to deliver cutting-edge solutions for customers. For the data center, Intel will build NVIDIA's custom x86 CPU and NVIDIA will integrate it into its AI infrastructure platform and offer to the market. For personal computing, Intel will build and offer the market x86 system on chips SoCs that integrated NVIDIA RTX graphic chiplet. This new x86 RTX SoCs will power a wide range of the pieces that demand the integration of world-class CPUs and GPUs. NVIDIA will invest $5 billion in Intel's common stock as purchase price of $23.28 per share. The investment is subject to the customary closing conditions, including required regulatory approval. AI is powering a new industrial revolution and reinventing the every years of the computing stacks from the silicon and systems and to software. At the heart of this reinvention is NVIDIA's CUDA architecture, said NVIDIA founder and CEO Jensen Huang. This is a historic collaboration tightly coupled NVIDIA's AI and accelerated computing stack with the Intel's CPU and the vast x86 ecosystem. A fusion of a world-class platform. Together, we will expand our ecosystem and lay the foundation for the next era of computing. Intel's x86 architecture has been a foundation to modern computing for decades, and we are innovating across our portfolio to enable the workload of the future, said Lip-Bu Tan, CEO of Intel. Intel leading data center client computing platform, and combined with our process technology, manufacturing and advanced packaging capabilities, will complement the NVIDIA's AI and accelerated computing leadership to enable the new breakthrough for the industry. We appreciate the confidence Jensen Huang and the NVIDIA team have placed in us with their investment and look forward to the work ahead as we innovate for customers and grow our business. Okay, the next stage. Taiwan proposes strategic tech alliance with the White House. Taiwan model would help companies invest easily in the U.S. to satisfy the demands. The U.S. and Taiwan have been engaged in months-long bipartisan trade talks since the Trump administration took over, negotiating the large round of the tech both ventures forward. According to the Bloomberg, the last progress stemming from the discussion is potential new high-tech strategic partnership dubbed the Taiwan Model. Vice Premier Chen Li-Chun, that would involve the Taiwan strike the balance between the domestic importance of the foreign soil influence. The deal largely echoes the prior development between the two nations has been formalized yet. The Taiwan model, put forth by the delegation sent to the U.S. during the September 25th to 29th, is essentially a proposal to keep the U.S. happy while ensuring the most Taiwanese chip production remains in the country. Vice Premier Chen Li-Chun had read the envoy, said that this alliance will help Taiwanese companies invest in America easily, letting the firms themselves choose how and where to put their money. Taipei will provide export credit guarantees and investment insurance schemes that would make it less risky for local businesses to invest in the United States. The country will also share its extensive experience in building science parks, allowing the U.S. to strengthen its own. In change, the U.S. will offer land, visas, and improved regulation to assist the effort. Both countries hold immense importance for each other, especially amidst the AI boom. Chang said that Taiwan model received positive responses from the officials and promising the sign following the country split out deletion of a proposal that Taiwan should move 50% of each chip manufacturing to the U.S. Taiwan said it not really agreed to such a move, which was one of the more controversial proposals floating around. Washington has been on a run to fortify the local chip manufacturing with various proposals and enacted policies, the most recent of which is the one-on-one rule, where the chip makers would have to make one chip in the U.S. for each chip imported from the abroad to avoid 100% tariff. Taiwan semiconductors are already exempt from the 20% of the reciprocal tariffs imposed the country, but it wants to extend the leniency across the board the Taiwan model, seeking to decrease these taxes overall. It also wanted the U.S. to make visa procurement easier for Taiwanese nationals and aid them in acquiring land along the retrieval regulatory protocol. Despite TSMC being heavily invested in the region with plans to manufacture even more high-end nodes there, Taiwan has previously made it easier to keep cutting-edge production local to its border, which are only 80 miles from the mainland China, applied to various U.S. officials. Commercial Secretary Toward Lutnick recently spread these concerns in an interview. The Chinese have said, "We're gonna take Taiwan." They are not even shy about it. Lutnick also teases a new semiconductor deal with Taiwan that was close to being finalized. Whether the delegation has cut through the red tape to catalyze that remains the seen. Leading UK semiconductor firm up for sale. A leading UK semiconductor firm has put itself up for sale and is in negotiations with the buyer. IQE in Wales makes wafers and substrate for companies to build compound semiconductor laser, photonics chip, and gallium nitride GaN chips for RF for power supply applications. Compound semiconductors are a key area for the UK semiconductor strategy, and the loss of IQE would be a significant blow to that strategy. It comes to a RISC-V Core tool, developed Codaship in Germany, is also up for sale, marking the potential loss of another flourishing European technology supplier. However, IQE is facing a cash crunch. Its negotiations with several companies for the sale of its operation in Taiwan, and the proceeds would be used to repay its revolving credit facility and provide cash to invest in its core operations. IQE has had a troubled few years, with its chief executive, Americo Lemos, stepping down suddenly in October last year. IQE CEO in shock departure. The company is expected to make a loss in the first half of this year on turnover of £44 million, $55 million. The full year revenue is expected to be around £100 million and $120 million, down from the $118 million in 2024. This would put the price at around $120 million. The loss comes from the deferral of a certain contract in the wireless and the photonics segment as a result of continued global and macro uncertainty. This slowed down the unwinding of inventory levels at customers built up 2023 and 2024, as well as lower spending in the U.S. military and defense sector, said Jutta Meyer, recently confirmed as the chief executive officer. QNAS completed industrialization of Ultra-RAM with IQE. There are a number of potential semiconductor firms that could be a buyer for IQE, and the company is in talks with one of them. Soitec in France manufactures engineered silicon wafers and IQ product in UPI. Complementary European chip maker ST Microelectronics is moving into photonics and already has a strong product range using semiconductor wafers and GNA chips, and favors vertical integration from wafer to device. However, it recently saw its first loss, and it is the process acquiring the MEMS business of NXP for $95 million. IQE is also working with the Belgian foundry XFABs on 100 to 1200 volt GNA parts, but XFAB is likely to remain a customer rather than a buyer. Outside of Europe, current in the US is leading substrate supplier, including photonics, and have no GaN business, but it's been closing and selling of wafer plants. SWI Packaging is a huge part of NVIDIA's $5 billion Intel deal. Foveolo could speed up the market delivery. The Foveolo and the EMIB are doing more than stacking dice. They are accelerating NVIDIA's roadmap. The Intel isn't a most obvious partner for NVIDIA. The two companies has competed across customer, data center, and AI markets for decades with no shortage of friction. But on a joint, not just Apple anymore. The NVIDIA and Intel announced jointly developed the Intel x86 RTL SoCs for PCs with NVIDIA graphics, and also custom NVIDIA data center x86 processors. NVIDIA buys $5 billion in Intel stock in systematic deal. In a surprise announcement that finds two long-time rivals working together, NVIDIA and Intel announced today that the companies will jointly develop multiple new generations of x86 products together. A seismic shift with profound implications for the entire world of technology. Before the news broke, Tom's Hardware spoke with NVIDIA's representatives to learn more details about the company's plan. The product includes x86 Intel CPUs and tightly fused with the NVIDIA's RTX graphics chiplet for the customer's gaming PC market, named the Intel x86 RTX SoCs. NVIDIA will also have the Intel build custom x86 data center CPUs for each AI product for hyperscale and enterprise customers. Additionally, NVIDIA will buy $5 billion in Intel common stock at $23.28 per share, representing a roughly 5% ownership stake in Intel. Intel stock is now up to 33% in the pre-marketing trading. The partnership between the two companies is very early stages. NVIDIA has told us that the timeline for product releases, along with any product specification, will be disclosed at the later unspecified data. Given the traditional long times for a new processor, it is rational to expect these production will take at least a year and likely longer to come to market. NVIDIA emphasizes that the companies are committed to multi-generation roadmap for the co-developed product, which represents a strong investment in x86 ecosystem. But NVIDIA representatives tell us it also remains fully committed to other announced product roadmaps and architecture, and including the company's ARM-based GB10 Grace Blackwell processor for workstation and NVIDIA Grace CPUs for the data center, as well as the next generation Vela CPUs. NVIDIA said it also remained committed to products in its internal roadmaps and they haven't been publicly disclosed yet, indicating that the new roadmap with Intel will merely be additive to existing initiatives. NVIDIA hasn't disclosed whether it will use Intel Foundry to reproduce any of these products yet. However, while Intel has used TSMC to manufacture some of its own recent products, its goal is to bring a production of most high-performance products back into its own foundries. Some products never left. For instance, Intel's existing Granite Rapids data center processors using the Intel 3 node, and the upcoming Clearwater Forest Xeons will use Intel's own 18A process node for computing. This suggests that at least one of the NVIDIA's custom x86 silicon, particularly for data centers, could be fed into data nodes. Intel also used TSMC to fabricate many of its client x86 processors. However, so we won't know for sure until official announcements are made, particularly for the RTX GPU chiplet. In either case, the NVIDIA has been using the Intel Foundry since 2022, has fab to test chips there, and participated in the U.S. Defense Department LAMPC product with the RTL. The DoD project involved NVIDIA's already making chips in the Intel's 18A process node, and it wouldn't be a total price. But while the two companies have engaged in heated competition in some market segments, Intel and NVIDIA has partnered to a decade, ensuring the interoperability between their hardware and software for products spanning both the client and data center market. The PCIe interface has long been used to connect Intel CPU and NVIDIA GPUs. The new partnership will find tighter integration using NVIDIA and NVLink interface for CPU to GPU communication, which offers up to 14 times more bandwidth, along with a lower latency than PCIe, thus granting the new x86 product access to the highest performance, possibly when paired with the GPUs and their strategic advantage. Let's dive into the detail we've learned so far. The Intel x86 RTX SoC for the PC gaming market. For the PC market, the Intel x86 RTX SoC chips will come with the x86 CPU chiplet tightly connected to an NVIDIA's RTX GPU chiplet via the NVLink interface. This type of processor will have both CPU and GPU units merged into one compact in-chip package that externally looks much like a standard CPU, rivaling AMD's competing APU product. Intel new x86 RTX CPU and will compete directly with AMD's APUs, and for AMD that means its interface is identifying the competition from a company with the leading market share in notebook CPU. Intel ships 79% of laptop chips worldwide, and that's now armed with the CPUs packed from the NVIDIA, which is 92% of the world gaming CPUs. This type of tight integration packs all the gaming processes into one package without an external discrete GPU, providing power and footprint advantages as much. We are told that a chip will be heavily focused on thin and writing, aiming the laptops and the small form factors PCs, much like today's APU from AMD. However, it's possible the new NVIDIA Intel chips could come in multiple flavors and permit further in the Intel stack over time. Intel has worked a similar type of chip before it with AMD. There is at least one significant technical difference between these initiatives. However, Intel launched its Kaby Lake G chip in 2017 with the Intel processor fused into the same package as an AMD Radeon GPU chiplet, much is the same as the description of the new Intel NVIDIA Intel chips. You can see the image of the Intel and AMD chip below. An RTL GPU chiplet connected to an Intel CPU chiplet via the fast and efficient NVLink interface. This SoC has a CPU at one end connected via a PCIe connection to the separate AMD GPU chiplet, which is frankly by a small dedicated memory package. The separation memory package was only usable by the GPU, and the NVIDIA Intel product will have an RTX GPU chiplet connected to the CPU chiplet via the faster and more efficient NVLink interface, and we are told it having a uniform memory access UMA, as meaning that both CPU and GPU will be able to access to the same pool of memory. Given the particulars of the NVIDIA's NVLink fusion architectures, we can expect the chips to communicate via a refined interface, but it's unlikely that will be leveraged NVIDIA's C2C, chip-to-chip technology, an inter-die, inter-chip, interconnect based on ARM protocols that aren't likely optimized on x86. Intel notably exited the Kaby Lake G product in 2019, and the existing system were left without a proper driver compute support for quite some time. In part because Intel was responsible for validating the drivers and then fingers pointing then should, we are told that both Intel and NVIDIA will be responsible for their respective drivers for the new models, with NVIDIA naturally providing its own CPU processors, drivers. However, Intel will build and sell the consumer processors. We haven't spoken with Intel yet, but the limited scope of this project means that Intel's proprietary Xe graphics architecture will most assuredly live on as the primary integrated GPU, iGPU, for its mass market production. NVIDIA's first x86 data center CPUs. Intel will fabrication custom x86 data center CPUs for NVIDIA, which NVIDIA will then sell as its own product to enterprise and data center customers. However, the entirety and the extent of the modification are currently unknown. We know that NVIDIA will employ its NVIDIA interface, which suggests that the chips could leverage NVIDIA's new NVLink fusion technology for customer CPU and accelerators, and enabling faster and more efficient communication with NVIDIA's GPUs than is possible with the PCIe interface. Intel has long offered custom Xeon to its customers, primarily hyperscalers, often with relatively minor tweaks to clock rate, cache capacity, and other specifications. In fact, these mostly slightly modified custom Xeon models once comprised more than 50% of the Intel's Xeon shipment. Intel has endured several years market share errors due to the AMD's advances, most accurately in the hyperscale market. Therefore, it is unclear if 50% number will hold true, as hyperscaler were the primary customers for custom models. Intel has said it is designed completely custom x86 chips for customers as part of its IDM 2.0 strategy. However, cited the recent announcement of customer AWS chips that sound likely slightly modified Xeons mentioned above, we have the heart of any large-scale uptake for significantly modified custom x86 processors. Intel announced the new custom chip design unit just 2 weeks ago. It will be interesting to learn the extent of the customization for NVIDIA x86 data center CPUs. NVIDIA already uses Intel Xeons in several etch systems, like the NVIDIA GB-XP300, but these systems will use the PCI interface to communicate with the CPU. Intel's new collaboration with NVIDIA will obviously open up a new opportunity given the tighter integration with NVLink that all the advantages it brings with it. The likelihood of the AMD adopting the NVLink fusion is somewhere around zero, as the company is heavily invested in its own Infinity Fabric, SGMI, and Ultra Accelerator Link UA-Link initiatives, which aim to provide an open source, open standard interconnected driver NVLink and democratize rack-scale interconnect technology. Intel is also a member of UA-Link, which uses AMD's Infinity Fabric protocol as the foundation. Dollar and cent geopolitics. NVIDIA's $5 billion purchases of Intel common stock will come at $23.28 a share, roughly 6% below the current market value, but several aspects of this investment remain unclear. NVIDIA hasn't stated whether it will have a seat on the board, which is unlikely, or how it will vote on matters requiring the stakeholder approval. It is also unclear if Intel will issue the new stock primary insurance for NVIDIA to purchase, as it did when the US government recently became the Intel shareholders. That is likely. Naturally, the investment is subject to approval from regulators. NVIDIA's buy-in comes in the heels of the US government buying a $10 billion of newly created Intel stock, greenlighting the country's a 9.9% ownership stake at a 20.47 per share. The US government won't have a seat on the board and agreed to vote on the Intel's board to matters requiring shareholders' approval with limited exceptions. SoftBank has also recently purchased $2 billion worth of the primary issuance of Intel stock at $23 per share. So the U.S. government said it invested in Intel, the goal bolstering U.S. technology, manufacturing, and national security, and the investment from the private sector also helped solidifying the struggling Intel. Although these investments represent a significant cash influx for Intel as it attempts to maintain the heavy capex investment required for competing with the TSMC, or while struggling with the negative amount of free cash flow. AI is powering a new industrial revolution and reinventing every layer of the computing stack, from the silicon to systems software. At the heart of this reinvention is NVIDIA's CUDA architecture, said NVIDIA Jensen Huang. This historic collaboration tightly covers NVIDIA's AI accelerated computing stack with the Intel CPUs and vast x86 ecosystem, a fusion of the two world-class platforms. Together, we will extend our ecosystems and lay the foundation for the next era of computing. Intel x86 architecture has been a foundation to modern computing for decades, and we are innovating across our portfolio to enable the workload of future. And the Intel CEO Julie Bhutan, Intel's leading data center and client computing platforms combined with our process technology, manufacturing, and advanced technology capability will complement the NVIDIA's AI accelerated computing Intel leadership to enable breakthrough for the industry. We appreciate the confidence that Jensen Huang and the NVIDIA's team has placed with us their investment and look for the work ahead. As we innovate for customers and grow our business. Okay, thank you for your time. See you next. Thank you for your time. See you next time.